Okay, so my name is Julian Tabamu from BAT4D. Listen to reporting about reconditioning and recirculation of water. Where the ability of good quality water is limited, tourists have to resort to reconditioning and recirculation. In certain circumstances, it may also be considered necessary to reduce risk of infection by pathogens and parasites through continued use of water from external sources. So, meaning, ang mga hatchery daw is need mag-apply og reconditioning o recirculation kung ang magadang kalamidad sa tubig or water is limited lang. On the other hand, needs sab ni siya or essential para malikayan ang mga treat sa mga pathogen or parasite gikan sa continuous nagpagamit og tubig from the outside source. So unsa man kini na mga when the water has to pass through a series of tanks, it has often been the practice in hatcheries to pump the water through an aerator. After it has passed through a certain number of tanks before further distribution. Kung ang tubig is moagi og mga tangke, which is very common sa mga hatchery na magbomba og tubig through aerator, then kini na proseso is nasab siya panganib ang kaning mga simpleng sistema ng recirculation. Naturally, there are intrinsic dangers in such simple systems of recirculation. Pure oxygen can be replenished through aeration and most of the carbon dioxide dissipated. The removal of metabolic products like ammonia will involve more complex systems which besides re-aeration and mechanical refiltration may involve biological treatment. Through aeration, pwede mawala or ma-replenish ini oxygen at ay karamihan sa carbon dioxide. On the other side, sa aeration at mechanical filtration, maaring may kasamang biological na paggamot. Recent designs of semi-closed systems employ one or more bypass treatment units, such as for denitrification, oxygenation, ozonization, etc., and principles such recirculation should make it economically feasible to grow warm water species in temperature climates by reducing the cost of heating. In practice, there are many constraints to its application in commercial aquaculture, but it can be used in hatchery situations with essential. So, naay mga recent design which it talks about sa mga oxygenation, ozonization, and ammonia can be removed by nitrifying bacteria. Ammonia is first converted primarily by nitrosomonas to nitrous acid, then by nitrobacter to nitric acid. The acid combines with an available base to form nitrates and then nitrates. Nitrates are harmless in the recirculating system, even in prolonged exposures in culture systems. New toxic systems, new toxic effects have been reported below 100 mg 1 nitrate nitrogen Wickens 1981. Nitrate toxicity is influenced by water chemistry, but it has been suggested that concentrations in hard freshwater should not exceed 0.1 mg 1 nitrate nitrogen and in seawater 1.0 mg 1 nitrate nitrogen. So, maaring alisin ang ammonia sa nitrifying bacteria, din ang nitrates daw is dili siya nakapinsala ng chemical sa tubig, pero minumungkahi na ang concentration sa sariwang tubig dapat dili molagpas sa 0.1 mg 1 nitrate nitrogen at sa tubig dagat 1.0 mg nitrates nitrogen. The most commonly used and relatively more economic treatment will appear to be biofiltration, which may incorporate downflow filters, trickling filters, upflow, upflow filters or horizontal flow filters. Several types of filter media are in use such as sand, gravel, oyster shells, plastics, anthracite, activated carbon, diatomase, earth and their combinations. Besides serving as strainers, they provide surface area for biological growth and oxidation. Ammonia is converted into nitrate and nitrate. The nitrate may be further combined with ions in water to form salts or reduced to nitrogen gas through a denitrification process. According to Liao and Mayo, 1974, with retention time of about 30 minutes and hydraulic loading rate of 1.0 to 3.0 ice per M2 about 48% for the initial ammonia load can be removed. A rotating biofilter process is employed as a secondary treatment. The basic unit consists of a half-cylinder tank, through the ends of which a horizontal shaft is mounted. As wastewater flows through the cylinder, the discs, which are half submerged, are rotated. A layer of microorganisms grows on the discus and acts as the aerobic biochemical agent to remove the dissolved waste from the water. So, ini process sa biofilter, ginagamit daw siya sa second treatment, which is gibuo siya og isa ka tangke na half cylinder. Ang isa sa layer ng microorganism is mudako siya sa mga days of serve as aerobic biochemical agent upang alisin ang mga natunaw na dumi mula sa tubig. Ion exchange is an efficient and reliable means of ammonia removal, but it is much more expensive than biological filtration. Clinoptilolite, one of the zeolites used in water treatment, is an effective natural ion exchange material for the removal of ammonia from hatchery water. It has a high selectivity for hatchery water. Ang ion exchange is good of trusted treatment po ni siya sa ammonia removal pero mas mahal lamang kay sa biological filtration. Ang clinoptilolite isa pod sa mga zeolites na gigamit para sa pagpalitan ng ion para sa pag-alis ng ammonia gikan sa hatchery water. Although in principle it is possible to use aquatic plants, including algae, to remove metabolites and nutrients from water. Through assimilation or biological conversion, there are practical difficulties, particularly for use in connection with a hatchery system. Another means of reconditioning water is through the use of an activated sludge process, in which biological oxidation occurs in the fluidized suspension of the sludge. Mention may also be made of the use of ozone, which is a very strong oxidizing agent and oxidizes the organics in the water and at the same time serve as a disinfectant. However, it is used in hatcheries has not progressed beyond the experimental stage. Although although daw pwede sa mogamit og aquatic plants like algae para ma-remove ang metabolite at sustansya mula sa tubig through a simulation o biological na conversion is naa daw difficulties. Ang isa sa way na reconditioning ng tubig is through use ng isang activated sludge process, which is any biological oxidation ay mangyayari na sa fluidized suspension ng sludge. In all these systems, there is the need for the regular supply of make-up water at a rate of at least 5 to 7% of the total volume to replace the losses due to filter, backflushing, draining of the sludge, and evaporation.
That's all, thank you.